All right, so the difference between stoichiometry and mole conversions, as you can see on the front part of the packet, is the idea of a mole ratio. And so mole ratio is looking at how many of each substance do we have that's either reacting or being produced inside of a chemical reaction. And so when we're looking at this, we're still going to be considering grams. The difference here, though, is that when we're going from grams of a certain substance. We're going to call it grams of A. From here, we can go to, and I'm actually going to delete this as to not confuse, but we can go from grams of A to moles of that substance. And again, we'll kind of brush this up in the examples that we have. But we have grams of one substance to moles of that same substance. That's what A represents. But then when we get into here is a change of substances. And so now we can see that we're going to moles of a separate substance, moles of B, and then finally we can go to grams of B. So in here, the main thing that's changing is the fact that we're seeing right here this idea of a mole ratio. Now again, this mole ratio is saying how many of each substance we have, and where we get that is in this little space, aka the coefficients of each of these substances. And so we can see in here, even though it's not named, that we have 1 copper being added to 2 silver nitrates. So that's a 1-to-2 mole ratio. So when those are reacting, we have this ideal ratio of 1-to-2. And as a result, what we get is 2 silvers and 1 copper nitrate. So we're seeing again the fact that in this reaction, as it's balanced, we're seeing a perfect ratio of 1 copper to every 2 silver nitrates, and as a result, we're getting 2 silvers and 1 copper nitrate. So as we look at these different examples, we'll use purple because that's a nice color. We can again take a look, keep an eye on this little roadmap that we can call it. Again, focusing on this new thing of a mole ratio. So for the first example, number 3, it says how many moles of silver are produced when 5.3 moles of copper are reacted. So we're going to start it the same way that we've been doing. So we're starting with 5.3 moles of copper. We know that that's a reactant, hence why it says moles of copper reacted. And now what we're doing is we're going from, if we look at the top, we're going from moles of A to moles of B because we're going to moles of silver, a new substance. So when we consider this, we're still looking at keeping moles of copper on the bottom in order to cancel these out, right? That's why we put it on the bottom. And we can see in this for number 3 that we have 1 mole of copper reacting. And for every 1 mole of copper that reacts, we get 2 moles of silver being produced. So we put 2 moles of silver. So we're getting this mole ratio from our balanced equation. When we do that, we're left with moles of silver, which is what we want. So 5.3 times 2, again, that the 2 and the 1 for moles of silver and copper do not affect our significant figures. So in this case, we would get 10.6 moles of silver, but because of significant figures, we're going to round up, and we get 11, moles of our silver that is being produced. So that's how we do this. Again, we're looking at that mole ratio and trying to figure out how much, if we get this much reacting, how much do we get produced, or if we're producing this much, how much must have reacted. So we'll do one more example with this in number 4, and we can go from there and kind of see what's going on. So in this case, it's having us actually we're gonna skip down to number 5 here because number 4 is similar. We're just going from moles to moles. So we'll bring in some grams here so we can see how this works itself out. So number 5 reads, how many moles of copper 2 nitrate are produced when 1,000 grams of silver are produced. So we're looking, in this case, both at the product side, but we're going to go ahead and take our 1,000.00 grams of silver. All right, so we notice that we have 6 significant figures here. Counting is hard. So we have 1,000.00 grams of silver being produced. And so we're trying to figure out how many moles of copper 2 nitrate are produced. So in this case, we're starting at grams of substance A. We're just going to call whatever we start with substance A, and then whatever we're going to as substance B. So we're going from grams of A to moles of B. So we know we have to go 2 steps, from grams of A to moles of A, and then from moles of A to moles of B. So in this first step, we're going to go from grams of A, which in this case is grams of silver, to moles of silver. All right, and we know for every 1 mole of silver, we can look at our molar mass that we found up here, and that we have 107.9 grams of silver. We know units will then cancel out, but we're not done yet, because now we have to go from moles of A to moles of B. We got to go back through that mole ratio. So when we're doing this, we're going to have moles of silver on bottom, and because we're going to copper nitrate, we got to put moles of our copper nitrate on top. Whoop, there we go. All right, so again, mole ratio comes from our balanced equation. So if you have an unbalanced equation, your mole ratio is going to be off, giving you a wrong value, so you got to make sure that that balanced equation is written correctly. And we know that for every 2 moles of silver that's produced, we get 1 mole of copper nitrate being produced, and we know our moles of silver cancel out. So as we plug this in, I got to pull up my calculator here. So as we plug this in, we're doing that 1,000. I'm going to multiply everything on top, so times 1 times 1, and we know that anything times 1 is itself. But now we're going to divide by those numbers that are existing in the denominator. So we divide by 107.9, and then again we divide by 2. And so what we end up getting here is 4.6339. All right, but again, significant figures tell us that we can't have that. The most we can have, due to our molar mass of silver, is 4 significant figures. And so when we do that, we're going to write 4.634, and now we got to have units. That's the last thing. Moles of our copper nitrate. And that would be the answer that you would be solving for. So when we do this again, we just have to remember that as we are going through, the difference between this and our mole conversions is the fact that here we're going through a mole ratio, but it allows us to go from one substance to another given a balanced chemical reaction.